Hi, it's Alan Begg here from MacMaths, and welcome to today's lesson. Today's lesson is going to be part one of a series of lessons on change of subject of formula. Part one is going to be on addition. So, what is change subject of formula? Here is a typical example of an algebraic formula. Z equals x plus y. In this formula, Z is what's called the subject. Z is the subject of this formula. Whereas x and y are the variables. Change subject of formula is changing the subject of the above formula from z to either x or y. As it's laid out just now, z equals x plus y, z is the subject. Change subject of formula would be changing the subject to either x or y, and the consequential impact on the formula that change would have. When we know the values of x and y, we know that z equals x plus y. But if we know the values of z and y, what does x equal? How do we rearrange the formula to make x the subject? That's the purpose of change subject of formula. Changing the existing subject to one of the other variables and making that the new subject. If we know the values of z and x, what does y equal? How do we rearrange the formula to make y the subject? Change subject of formula is moving variables or numbers from one side of the formula to the other side of the formula to make them the subject. At the moment, z is the subject. Change subject of formula, we'll be making either x or y the subject. And you do that by moving x or y from one side of the formula to the other side of the formula. But there's rules as to how you do that. Whatever operation the variable or number is doing on one side of the formula, it must do the opposite on the other side of the formula if you move it from one side of the formula to the other. This is called the inverse operation. Let's read that again. Whatever operation the variable or number is doing on one side of the formula, it must do the opposite on the other side of the formula if you move it from one side to the other. This is called the inverse operation. There's rules to follow, as I mentioned earlier. Rule number 1. If you add a variable or number on one side of the formula, you must subtract it on the other side of the formula. That's what the inverse operation is. Rule 2. If you subtract a variable or number on one side of the formula, you must add it on the other side of the formula. Rule 3. If you multiply by a variable or number on one side of the formula, you must divide by the variable or number on the other side of the formula. Division being the inverse operation of multiplication. Rule 4. If you divide by a variable or number on one side of the formula, you must multiply by that variable or number on the other side of the formula. Multiplication being the inverse operation of division. When you change a subject of a formula, the new subject must be written as a positive. It can never be a negative. When you change a subject of a formula, the new subject must be written as a positive and never a negative. The actual result, once you've worked out the formula, might be a negative number, but the letter of the new subject must be written as a positive and never a negative. For example, x equals z minus y is okay. You can write it like that, but you cannot write minus x equals z minus y. You can't have the new subject as a negative. Once you substitute the actual numbers in to x equals z minus y, x might equal a negative number. That's okay, but you can't start with negative x. X equals z minus y is okay. Minus x equals z minus y is not okay. You can't write it like that. For example, x equals z minus y. If we know z equals 20 and we know y equals 5, x equals 20 minus 5 equaling 15, which is right. Of course, you don't actually put the positive in front of the x ever, but it technically does have a positive in front. We just never write it. In this example, the resultant is a negative number. C is 10 and A is 15. B equals C minus A. B equals 10 minus 15, which ends up being minus 5. So the answer is okay to be a minus figure, but you must start with a positive subject. So a reminder, Positive subject is okay, negative subject is not okay. Let's look at some examples. X plus y equals z. We're going to change the subject of this formula to x. What do we have to do with the y and the z to make x the new subject? Let's remember rule 1. If you add a variable or number on one side of the formula, you must subtract it on the other side of the formula. This is called the inverse operation. Subtraction being the inverse of addition, the opposite. X plus y equals z. To change the subject to x, the result is x equals z minus y. We had plus y on the left hand side. We want to move the y to the right hand side. So we've changed it from adding y to subtracting y. That's rule 1. It was plus y, it's now minus y. Let's look at some real numbers for that change of subject. X equals z minus y, z equals 5, y equals 3, so x equals 2. X equals 2 is the answer. Let's check by substituting some real numbers in and check that the formula is balanced. If the formula is balanced, we know we've done it correctly. Here's what we've worked x out to be. We were already given y and z. Have we worked out x correctly? Let's substitute those numbers in. 2 plus 3 equals 5. That's correct, it's balanced. The result on the left hand side is the same as the result on the right hand side. 2 plus 3 equals 5, and we knew already that z equals 5. 5 on one side, 5 on the other side. Balanced. X plus y equals z. Change the subject of the formula to x. Rule 1 again. Add on one side, subtract on the other side. We're moving y from the left hand side to the right hand side, so we switch to the inverse function. Adding y on one side, subtract y on the other side. Let's check what x would be with these variables. Z is 48, y is 12. X equals 48 minus 12, which equals 36. Let's put those numbers in and check again to make sure that the formula is balanced. It's the same on one side as the other. We were given y and z at the start. We've worked out x to be 36. Is that correct? Let's substitute those three numbers in for letters. X plus y equals z. 36 plus 12 equals 48. So 36 plus 12 is 48. We knew already that z was 48, so this formula is balanced. It's correct. X does equal 36. Another example. X plus y equals z. This time we're going to change the subject to y. The easiest way to start this off is by reversing the variables on the left hand side. Instead of having x plus y equals z, change it to y plus x equals z. Y plus x equals z is the exact same as x plus y equals z. And here's proof. Let's put these numbers in. 3 plus 2 equals 5 is the exact same as 2 plus 3 equals 5. All you've done is switch the numbers around in terms of the order of addition. The sum is the same, it doesn't matter which order you add the variables in. So, first step, we've changed it from x plus y equals z to y plus x equals z. Just by shifting around the variables. Remember our rule? Add on one side, you must subtract on the other. You must do the inverse operation. Y plus x equals z. Move the x from the left hand side to the right hand side, and then remember to change the sign. We're adding x on the left hand side. If we move it to the right hand side, we must subtract x because that's the inverse function. Let's put some numbers in again. We know that z is 5 and x is 2. What does that give us for y? Z is 5, x is 2, 5 minus 2 equals 3. So y equals 3. Let's check that by substituting the values in and see if the formula is balanced. We were given x and z, 2 and 5 respectively, and we've worked out y to be 3. Is 3 correct? X plus y equals z. 2 plus 3 is 5, and we knew that z was 5. 5 on one side, 5 on the other side. It's balanced. 3 was the correct answer. Another example. X plus y equals z. Change the subject of the formula to y. Remember, first step, instead of having x plus y equals z, switch around the variables to make it y plus x equals z. We know this is okay to do because 3 plus 2 is the same as 2 plus 3. Doesn't matter which way round you have the variables, the sum is the same. Switch the variables, change it from x plus y equals z to y plus x equals z. Our rule 1, add on one side, subtract on the other, the inverse operation. Y plus x equals z. We've moved the x from the left hand side to the right hand side, and we've changed the function, made it the inverse, adding x on one side, subtracting x on the other side, and that now has y as our subject. We've changed the subject from z to y by isolating y on its own. These are the numbers we're going to use for the variables z and x. What y does that give us? Y equals 48 minus 36, and that equals 12. Y equals 12. Let's check to make sure that that is correct. We do that by substituting all of those numbers into the formula and ensuring that the formula is balanced. We were given x equals 36 and z equals 48. We've worked out that y equals 12. Is that correct? X plus y equals z. 36 plus 12 equals 48. 36 plus 12 is 48, and 48 on the other side. It's balanced. 12 was the correct answer. Another example. A plus B plus 10 equals C. This is the first example we're doing where it's not all just letters. We've got a number as well. The objective is to change the subject to B. Currently, the subject is C. C is isolated on its own on one side of the formula. C is the subject, and we want to change it to B. How do we go about that? Step 1 is always have the new subject on the left-hand side. What we've done here is we've moved B from the second variable to the first variable. We know from previous examples it's okay to change the order of the variables that you're adding because it ends up being the same result. Here's some examples to prove that that's the case. 3 plus 2 plus 10 is 15 is the same as 2 plus 3 plus 10 equaling 15. So it's okay to switch the 2 and the 3 in the same way that it's okay to switch the A and the B from our formula. That's okay, we can do that. That's step 1. Remember the golden rule? Add on one side, subtract on the other. Step 2 is to move the variable A from the left hand side to the right hand side. At the moment we have b plus a plus 10 equals c. Let's now move the a from the left hand side to the right hand side. That would give us b plus 10 equals c minus a. We've moved the a from the left hand side to the right hand side, and we've changed to the inverse function, adding a on one side, subtracting a on the other side. Leaves us at the moment b plus 10 equals c minus a. But we need to keep on going because b is not isolated on its own. It's still got this plus 10. Next step is to move the plus 10 from left hand side to right hand side. This is where we are. B plus 10 equals c minus a. Move it from the left hand side to the right hand side gives us b equals c minus 8 minus 10. We've moved the 10 from the left hand side to the right hand side, and we've switched the function to the inverse. Adding 10 on one side means subtracting 10 on the other side. Now we've isolated b on its own. B equals c minus a minus 10. Let's try it for these variables. C equals 15, a equals 2, and obviously 10 remains 10. Let's fire them into the formula. 15 minus 2 is 13, minus 10 is 3. So b equals 3. Let's check by substitution to make sure that that answer is correct. Is the formula balanced? Let's fire the numbers in. A plus b plus 10 equals c. A equals 2, b equals 3, and c equals 15. And of course, 10 just remains 10. Is b equals 3 the correct answer? A plus b plus 10 equals c. 2 plus 3 plus 10 is 15, and 15 on the other side for c. 15 on one side, 15 on the other side. It's balanced. 3 was the correct answer. As always, I hope you found that interesting and informative. The next part of this short series will be on subtraction, change of subject of formula, and we're going to do subtraction. This is Alan Begg from McMaths, signing off until the next time. See ya.